So that is, I'm just shortening it now. This is sort of the view we have right now. So there is presumed correlates of conscious perception are either people talk about amplitudes and just say, okay, there you have a neuronal population which has more or less activity with your perception. So here we would look for the firing rates of the neurons or neuronal oscillations in a certain frequency and just look at the power, at how strong those oscillations are. And there are what I would call like communication models which think that neurons have to oscillate in a certain frequency to actually integrate a percept. So now the question is still what in our neuronal correlates of consciousness, what are the prerequisites? I mean, what is just enabling the percept or the content? And what are the consequences and what is the actual substrate? And that's a cartoon. I don't really believe in it. Yeah, but in terms of neuronal correlates, you would find a lot of modulation here, here not so much, and here you also find a lot of perceptual modulation in the frontoparietal networks. But what does it actually mean? And what is really causal to it? And one way of investigating this question is to just cut out the report. So if you remember that scheme, so when we try to assess the correlation between the awareness and the brain state, we always have a behavioral indication and a measure of brain activity. There is this way there where you could basically study all the neuronal correlates of a behavioral indication and then try to see what's left, sort of. But that's a very complicated way of doing it, and I think it's, yeah, so you may be busy forever, but you can also cut out the report, or you can interfere with brain activity and see what's causal about it. That may be a quicker way of doing it. So all the approaches are valid. We concentrate now in the remaining time just on a couple of areas, because obviously you need to choose where to start from. So we are going to look at the effects of V1 lesions, of parietal lesions, and as an example for a thalamic nucleus at the pulvinar. So what happens when you lesion V1? So the first order processing stage in the cortex for visual information, what happens when you lesion it? The lesions, they usually come by strokes. Bilateral V1 lesions you get with hypoxia, for example, but they are rare. In most cases, it is a stroke that also is not affecting whole V1, but just parts of it. And the effect would be that people complain, or patients complain, about the loss of the visual information in a certain space. And so they would usually say it's not black, there's just nothing. So also difficult to imagine. I always wondered, but. So the questions we can address here is what sort of visual functions you can still have without a primary visual cortex, and which functions remain after visual consciousness is gone. It's two different questions. I don't know whether you understand the difference, but I feel it's important. So one question that can be addressed is what is the function of the visual cortex itself, and the other one is which functions remain when you lose your consciousness. This is actually not a study question. This is just for like to sort things. So interestingly, so those patients really would not report any qualia in this point of space that, or in this region of space that they are not aware of anymore. That was but you can force them to actually say, okay, do you see horizontal stripes, or was there motion, or where is the stimulus? And if you force them that way, they would say, and not all of V1 lesion patients show this, but it's a behavior that has been reported frequently after V1 lesions. People show what you would call blind sight. So that's the ability to make some sort of correct judgment. Also, without the experience of qualia or without being aware of the stimulus. So, for example, here the patient would say, okay, so I guess those are horizontal stripes, but would say that it's a completely stupid question because they actually didn't see anything. And V1 lesion patients have been reported to do all sorts of to have all sorts of visual abilities, so they can, for example, point to the location of a stimulus, detect movement, discriminate orientation of lines, discriminate shapes. Not all of them, but some.
So in this case, could you actually study the emergence of a new precept or a new percept? So if this person does this task once and they guess correctly, then they're going to have this just experience of, oh, I guessed correctly. If they do it 1,000 times.
Yes. This has also been discussed in this type of literature, exactly, that you can learn to somehow rely on cues. That's also the big danger of this type of studies. You're right, because you get some sort of feedback, you say, okay, yeah, so that must be correct, and whatever you took, then you don't take your qualia to judge it, but whatever other cue that is.
I'm actually thinking about it the other way around, which is that if you are doing this systematically for a very long time and you become familiar with the experience that you can guess correctly, then you may develop a feeling of being right. In other words, an ability to assess the confidence of your own guess because you've actually had repeated stimulus. So you might be able to actually see what happens in the brain when a new kind of percept develops that a person could not have actually had before.
So it doesn't need to be a visual concept. It could be also
some other thing.
Just a feeling that, yeah.
Who knows what it would be, right?
But in this case, thalamus still intact, like with the pathway during
the LGM would be still correct, intact, yes. Mm-hmm.
As to Nicholas' question now, some people have actually tested that kind of hypothesis by asking subject to wager high or low, depending on their answer.
Yeah.
And in fact, if you do that, these people actually do it completely randomly. So even though you have a motivation to earn lots of money, they can't utilize that kind of feeling.
Is that true? Is that true on repeated trial? That's what I'm wondering about. Not like if you do it once, I agree.
So this particular study was done on a really professional blind side.
GW.
Studied like 20 or 30 years old. Lots of knowledge came from that particular subject, and still that subject can't use that knowledge.
Just different question. Like when you say they can, you mean like above chance?
Yes, and this is actually the next study question I want to get to. Yes. So this blind side is usually taken as evidence what we can do without consciousness, what we can do without V1, but in fact, indeed, it depends on the task, but it's usually it's above chance. Let's say it's like about 60%. So it's not perfect, it's not 80, it's not 90, right? So then that's exactly my question here. So if you find this blindside patients, I mean, does it mean that we can actually, and does it above chance? Does it mean that you don't need V1 to be conscious, or you don't need conscious awareness to guide your behavior? I want you to think about that as well. In the literature, you find a lot class half full notions, but to me it's half empty.
And is a percentage depend on different tasks? Like a very simple look at line, it will have higher or lower?
Yes, so usually it's better if it's guided sort of visual motor behavior, like looking, pointing is better than having some perceptual judgment about line orientation, for example. I'm going to show you now the famous, that may answer your question. And this is a really amazing case because it's also clean in a way. So this is Helen, that's the very famous blindside monkey from the 70s. So this was the time when at the NIH they still did like huge, big, full lesions. So they really took off bilateral V1 in Helen, right? So Helen, here's Helen after a couple of months without a primary visual cortex, and she has not been in this obstacle park before. You see, it's just like sort of behaving as if she would see. obviously it's a little difficult because you can't ask the monkey about the experience, but what is clear that she has a visual guided behavior even without a V1. So I think that's fair to say. Okay, so perfect. Yes. So how does the monkey and how do the patients do it, right? Without primary visual cortex? Ah, yeah, genau, that's actually. Yeah. So not bad, huh? I mean, not V1. And Mortimer Mishkin, who is sort of the guru of neuropsychology, who has done like lesions really all over, and he was still around when I was a postdoc at the NIH, he would tell, it's not in the literature, but he would tell like this anecdotal story that he saw only really blind behavior when he on top lesioned the frontal cortex. And I've never found that in any of the papers, that's why I'm telling you. It was actually interesting. So the combination of V1 and frontal. Just frontal didn't work, just V1 didn't work, but the combination is really interesting. There are other dissociations between perception and action as well. So there are patients, for example, with optic ataxia who cannot say whether something like they are asked to just put a hand to some opening, and they would, for example, not be able, or the other way. In this case, they would be able to judge correctly the orientation of the slit, but they would not be able to put a hand correctly. And this is one of the illusions that I actually just discussed with Pete. This is called the phase illusion. So under certain lighting conditions, you can have the illusion that you have a phase coming towards you, or so it's actually shown inward. And the interesting thing is that your perception is the one of a phase that comes towards you, but your pointing movement is actually correct. So that's, yeah. This has been taken as evidence that there are like conscious and unconscious pathways. And there are also interesting dissociations, which I don't have the time because I really need to rush. But one of the prime paradigm that is used now for looking at what you can do without consciousness is actually now is CFS, and it turns out you can do all sorts of things. Basically, you don't need even for doing arithmetics and doing, yeah, basically right now, do you know any example where the CFS, any function that could not be subserved with CFS? Because the funny thing about really your CFS is that it looks
really complicated thing, or long-range integration in time and space seems to be difficult. But the cross-modal combination possible. The problem solving seems possible. It's weird.
Yes, it is very weird. And there's also, yeah.
Many things.
So, okay, so the presumed pathway goes like this. So retina, LGN, primary visual cortex, ventral stream, infratemporal cortex. That's like the feed-forward pathway, of course, also with feedback connections that I have talked about before. And there is supposed to be a second-order pathway that goes from the retina directly to the superior colliculus, pulvinar, posterior parietal cortex, and from there, it's so-called dorsal pathway. The LGN was not supposed to be a part of it, but I actually participated in a study that was made by Michael Schmidt, where we had a combination of V1 lesion, physical lesion, and an inactivation in the LGN, and actually turns out you lose your blind side if you lesion the LGN on top. So LGN is actually part of this pathway, so that needs to be revised. But I mean, the punchline is that there are really different, it seems that we have different pathways, one more for guiding behavior and the other one more for perception. And the next minute I'm going to spend on a really interesting syndrome, which is conceptually almost the opposite from blindsight, because those are patients that have the primary visual cortices intact, but they behave as if they are blind. For example, they would guide their whole behavior just towards one side of space. So they would, for example, bump into objects and then not being aware that they actually do have a problem, so complaining about the other person. They may not feel anything when they are touched at both sides at the same time, for example. That's called extinction. And by definition, in spatial neglect and extinction, like this pathway is intact. Okay, they don't have a problem with the retina or with V1, or yeah. So this whole pathway is okay. They seem to have more lesions in the posterior parietal cortex or in the temporal cortex. So it's not cortical blindness. And the brain areas that are involved in spatial neglect are sort of almost the same that have been proposed to subserve our general consciousness, which is frontoparietal, and the STG, which the superior temporal gyrus, which seems to be very important, and also subcortical structures. I'm sort of running out of time, but one of the major deficits you see in neglect is that they orient towards the side of the lesion, like even spontaneously, they just look to one side.
Yeah,
but I definitely show you this because it has been published 2001 in Journal of Cognitive Neuroscience. I think that's probably why it sort of fell under the radar. I find this a very important study. So what they did, they just let subjects judge it. It's really to the question whether the frontal parietal is somehow causal for your visual perception. Okay? And they just showed either one stimulus, so just one stimulus, and then they added the other one, and the task of the subject was just to judge which of the stimuli came first. Okay? And then they had two task versions. One was looking at the first stimulus, and the other one was to report with a button press which stimulus came first. And the interesting thing is that when the parietal patients, those are the ones which are on dotted line here, when they were supposed to just look at the first target, they clearly had a deficit. So the frontal lobe patients did not have any problem. But the parietal ones did, so they would have a bias towards the lesional side, but not when they actually use button presses. I find that a very important study we can talk about in detail later. But this indicates that the way you ask for your perceptual deficit really matters. Parietal lobe is not parietal lobe. I won't have to, yes. I still take this minute and show now my monkey.
Okay.
Yes.
Sure.
It's okay. Punchline is in the different cortical areas. You get in the parietal lobe. Okay, that's like the prime area that's supposed to subserve like visual consciousness and underlie spatial neglect, but you really get completely different deficits whether you inactivate locally, as we can do it in the monkey, just the medial or the lateral bank or so. In humans, you get that usually all stuff together, but if you really try to dissect it, you have just perceptual deficit, something that looks like a perceptual deficit, but this is just for the eye movement or just for the hand movement. That was important to me to say. And now, if you look, for example, in the pulvinar, which connects to the frontoparietal lobe, and which is sort of a logical node to subserve perceptual behavior, and it also had a huge amount of perceptual modulation in the task I have shown you. So you would have thought this is like a primary, like a major node for consciousness. If you lesion it, so this is not the monkey I show you, and then I can stop it. So this is a healthy monkey, just picking up stuff. It's a completely spontaneous task. This is not an overtrained task. And this is after the pulvinar inactivation. You see that she sort of gets stuck. You see that she doesn't pick up the contralesional items anymore, and so she sort of behaves as if she doesn't see it. So that would be a typical neglect-like behavior. You would observe it in a patient as well. But not that she's not hungry or anything, because if you move it, she does. Sort of behaving blindly. And then the last question is that perceptual, because it looks like that. Pulvinar had perceptual modulation when you lesion it, it sort of looks like a perceptual deficit. But then if you, for example, if you modulate the amount of reward the monkey gets, actually the deficit completely disappears. And luminance differences, for example, don't do that. Yes? So.